May we introduce you to the Swissbit XR DIMM, the extreme, rugged, small outline DDR3 DIMM for all applications that require special immunity against shock and vibration? Swissbit, in cooperation with the Small Form Factor Special Interest Group, has developed a rugged memory module called XR DIMM, the abbreviation XR standing for Extreme Rugged. System developers of rugged platforms had asked for a memory module family that should give them the same memory flexibility as with standard SODIMMs. Standard SODIMMs are not designed for ruggedness, and all measured to ruggedize them are only partially doing the job. The XR DIMM targets all of these requirements and offers a truly rugged solution at a competitive price. It uses a special connector that withstands heavy shock and vibration. It can be attached to the system board using standoffs, mounting holes, and screws. The module doesn't need more system board space than an SODIMM, including socket. It can be positioned above onboard memory and offer flexible memory upgrades between 1 and 8 GB capacity. The XR DIMM is available in speed grades up to DDR3 1600 and supports ECC error correction. Designers of rugged platforms face a difficult decision when planning their memory layout. Either they use memory components directly soldered to the system board, the most rugged but also expensive and inflexible solution, or they take standard SODIMMs and try to ruggedize them by using straps or glue in order to hold them in their socket. Each solution has its strengths and weaknesses. The strength of onboard memory certainly is ruggedness, but it comes with several disadvantages. The system board must be assembled with multiple different memory populations in order to offer various stock configuration units. This either increases stock keeping cost or lead time. Also, repair of weak or degraded memory components is expensive and risky. Last but not least, the system board manufacturer is not necessarily the expert in memory testing, something that should rather be left to the module experts. On the other hand, SODIMM sockets are the weak link of the standard module solution. Using straps or glue can help, but then easy replacement is no longer given. The XR DIMM offers the optimal solution. The socket is rugged by design. The module can be tightly attached to the system board. The capacity varies within a wide range. And the module comes 100% pre-tested, and if requested, with industrial temperature grade. System memory upgrade is as easy as using a screwdriver. And with on-time purchase of the memory module, the system integrator can use the declining DRAM cost to increase system profit. The XR DIMM uses a Samtec 240 pin vertical connector to interface to the system board. This connector has a similar routing as the DDR3 ECC SODIMMs, but offers more power and ground pins, and thus has a better signal-to-power ratio, which improves the signal margin. With 67.5 by 38 mm, the module is not bigger than a standard SODIMM, if you include the space needed for the SODIMM socket. The two mounting holes, with a diameter of 3.2 mm, allows one to mount the module to the system board and to secure the module against heavy shock. The module routing and SPD content follow the JE/DEC standards for ECC SODIMMs. This makes it very easy to replace an ECC SODIMM by an XR DIMM with little layout effort. The pin assignment of the XR DIMM has been defined in a way that the routing for ECC SODIMMs can be applied to an XR DIMM with only slight modifications. Although the XR DIMM has 240 pins versus 204 pins of an SODIMM, the location and sequence of the data, address, and command signals has been kept. Only small routing adjustments in the connector area needs to be done. Power delivery and signal shielding has improved due to the fact that the XR DIMM socket has 36 additional pins available, which are mostly used as power and ground pins. The pin-out comparison between XR DIMM and SODIMM shows the cleaner arrangement of pins on the XR DIMM socket. The SODIMM is inserted into its socket by sliding it angled in. between the contact rows and then pressing it down. The contact is created between the gold edge finger of the module and the spring contacts. The contact area, which is highlighted in red in this drawing, is relatively small. This socket does not offer generic ruggedness. The clamps holding down the module work against the spring force, and the module can jump out of the socket under heavy shock. And even if the module is fixed with straps or glue, the spring itself can lift off from the gold contact under vibration. This can cause intermittent bit failure. The module connection of XR DIMMs is made by two parts, a male and female connector that fit tightly and create a really stable contact. The XR DIMM connector has different spring types that create a much longer contact area. Also, the connector itself prevents movement of the DIMM against the system board. With the mounting screws and the special connector, the XR DIMM has passed shock and vibration tests up to 50 Gs shock and 12 Gs vibration along the three axes. There are multiple options to design a system with XR DIMMs. One option is to solder DRAM components to the system board as onboard memory. Memory channel 0 should be used to route these components. The extension socket with the standoffs allows one to add an XR DIMM module with the desired capacity and mount it to the system board. It is recommended to use memory channel 1 for this optional upgrade. Alternately, the system could use an XR DIMM on channel 0 and a second XR DIMM on channel 1. The XR DIMM connector for the baseboard is available with two different heights. This allows stacking of two XR DIMMs, one above the other. The XR DIMM is available in capacities from 1 GB to 8 GB. Speed grades reach DDR3 1600. Each module will be fully tested. Those with industrial temperature grade, even at -40 degrees Celsius and 95 degrees Celsius. XR DIMMs are currently available from 3 different module manufacturers, whereas Swissbit offers the most comprehensive portfolio and has the longest experience with the XR DIMM. Swissbit promotes a risk-free evaluation of the XR DIMM in your new system designs. As described earlier, the XR DIMM can be used as an extension module. Just design your next system with standard onboard memory. If the system is available, then just add the XR DIMM footprint and the standoff holes to the system board. All that is needed is the yellow marked space. Route the XR DIMM socket to channel 1. Now you have the opportunity to populate the socket, the standoff, and an XR DIMM just on a few evaluation boards. If it works well, you can introduce the XR DIMM to the series. If the XR DIMM does not fulfill your requirements, then just work with the onboard memory as you did before. Here again is shown the steps to introduce the XR DIMM to your system design. Design a conventional rugged system board with the first channel realized as soldered down onboard memory. Add the footprint for a Samtec BTH240 socket behind the onboard memory. Add mounting holes for the XR DIMM. Route the XR DIMM footprint with the second memory channel. Qualify your system board without XR DIMM. Assemble a BTH240 socket on an evaluation system. Add standoff to the evaluation system. Plug in an XR DIMM sample and evaluate the memory extension. Besides the ruggedness of the XR DIMM, the module has additional benefits. As already mentioned, you can easily repair or upgrade the system memory. The memory modules will already come 100% tested and will not see a reflow process that may damage DRAM cells. The XR DIMMs can be ordered just in time for the system assembly, which reduces your stock keeping cost. Additionally, the module can further be improved by underfill or conformal coating. XR DIMMs from Swissbit, the only truly rugged memory modules. Thank you for listening.